Hello, now we are talking about timer, which is 555 timer. We'll learn about the pin configuration of 555 timer, the basic architecture and operation. We'll look into the stable and monostable operation and how to use the timer in triggering circuit. And for the introduction, 555 timer is widely used because it is very stable and inexpensive device for generating accurate time delay or oscillation. And also it can provide time delays ranging from microsecond to hours, and it can be used with a very low power supply as low as 3 volt up until 18 volt, and it can source or sink up to 200 milliamp, meaning that as a source, or it can sink a very large amount of current. And it is compatible with both TTL and CMOS logic circuit. And also the IC, which is analog IC, can be used at a very high temperature and it is very stable. The range of the temperature to operate can be as low as minus 55 degree up until 125 degrees Celsius. This is an example of 555 timer as a sink, meaning that it is we can have a VCC connected to a lamp and to the output of pin 3, and as a result there will be a current flow from the power supply to pin 3, so it will sink the current to the ground. And this is another example of sinking of a monostable circuit. You see the red line from the plus 9 volt of the VDC to the LED and to the pin 3, into the pin 3, so the current will flow to the pin 3, so meaning that the 555 timer will sink the current to the ground. And as a source, this is an example of a circuit. So you connect the output of the 555 timer, which is pin 3, through the lamp and to the ground, so it will act as a source, providing a current flowing from the output to the ground. This is another example. If you see over here, the pin 3 is connected through the LED and to the ground, and R3 will limit the amount of current flowing. And 555 timer is used in several applications. Among others, if you look over here, it can generate a waveform, so it is a waveform generator, and with that we can have alarms, missing pulse detector, traffic light control, and so on. 555 timer is first introduced in 1971 by Signetic Corporation, and it is designed and invented by Hans R. Simonsen, and it is called the IC time machine. Okay, so if you look here, this is a picture of 555 timer. It is 8 pin, 4 on each side. It is dual inline, but also we can have in round metal can with 8 pin, and sometimes we can also have a 14 pin dual inline version. Okay, so each pin, if you look here, have a different function. For example, pin 1 is ground pin, so we have to connect the IC to ground in order for it to properly function. It is the most negative point of the IC. And then we have pin 2, which is the trigger pin. The trigger pin will be connected to the input of a comparator. We'll look into that later, and will be compared with 1/3 of VCC. Okay, and then the output pin, which is pin 3, it can be as a source or as a sink. And then we have a pin 4 reset. Usually the reset pin over here is active low, so meaning that if it is not used, if you want to have the 555 timer to function correctly, it will be connected to the power supply. Only when we want to reset, we connect it to the ground. And we have pin 5, which is the control voltage. The control voltage internally derive the 2/3 of VCC. Usually we'll connect it to the capacitor if you want to use it as a stable and monostable. Otherwise, it can be used by connecting a resistor to the ground or external voltage when we want to use the 555 timer as a VCO. And then we have pin 6, which is threshold voltage, and this threshold voltage usually is compared with 2/3 of VCC. Then we have a discharge pin, which is pin 7, when we want to discharge the value of a capacitor connected to the pin 7 to the ground. It is a short path to the ground if we want the capacitor to be discharged. And finally we have the power supply pin, which is pin 8. And for the pin 8, we can connect it to up to 18 volt usually. So this is the data sheet for the 555 timer. We can have 8 pin and 14 pin, and it can be in plastic, ceramic, and so on. This is the absolute maximum rating. So if you look over here, the power dissipation is very small, and the power supply, in the example, the maximum is 18 volt only, and the operating and storage temperature. Then we have the electrical characteristic. The minimum voltage is 4.5 volt in the example. Okay, we have a threshold voltage, so it is 2/3 of VCC. And then we have a trigger voltage over here, which is pin 2 usually. And we have other important parameters for the 555 timer. This is internal circuitry. This one is by Philips Semiconductor. So it is made from several transistors. In the example, we have about 24 transistors. And basically we have pin 3 output, the control voltage pin 5, VCC pin 8, threshold pin 6, trigger pin 2, reset pin 4, discharge pin 7, and ground over here. So this is another example by Texas Instruments. Also we have several transistors and also resistors. If you look over here, we have 28 transistors, Q28, and all these are the important, which is the pin number, and output is pin 3. All in all this internal circuitry can be combined into a several block, which is a comparator A, CA, and then we have comparator B, followed by a flip-flop. The flip-flop RS over here will determine the output, because it is connected to the output and also to the reset pin. So this is the reset pin. Transistor will control the pin, and also we have another transistor over here to control the discharge path. If it is on, there will be a path to the ground. And the important thing is we have 3 resistors over here. Each is 5 kilo ohm. So that's why the 555 timer is called 555. It is from the 3 resistors, each is 5 kilo ohm, connected from VCC to the ground. So this is the internal circuitry just now. So this is the position of the 5 kilo ohm, the another 5 kilo ohm, and another 5 kilo ohm. So we can have 2 value over here, which is for the threshold will be compared with 2/3 of VCC, and this one is 1/3 of VCC. And we have these 2 transistor for reset and discharge path. The internal circuitry of 555 timer will be different from one manufacturer to another manufacturer, but basically it still have a comparator, 2 comparators actually, A and B, the RS flip-flop or latch, and the 3 resistor 555. So this is all the pin number just now. Okay, and with all those pin number we can connect it to components outside the IC, and we can have a stable multi-vibrator circuit which is a free running. It is called free running because there is no stable state. It is always in unstable state, so it will move from high to low and so on, generating continuous strain of pulses. And the other one is the monostable multivibrator, or called one shot, where we have one stable state. So meaning that the output pin 3 will have a stable state, and when we trigger at pin 2 it will go to unstable state. When we talk about square wave, we have to talk about duty cycle. Duty cycle is actually the time T high with ratio of T high over the total time or period. It is T high divided by T high plus T low. Okay, or sometimes it is called T1, and for T high it is sometimes called as T mark, or simply Tm, or T on, and for the T low it is sometimes called T space, Ts, or T off. And duty cycle can be expressed in percentage, which is simply T high divided by capital T, the period, multiplied with 100%. And this is an example of duty cycle. The top one is 90% duty cycle, which is the time high is longer than the time low. And for the middle example, the time high and time low, or mark to space ratio, is equal. So the duty cycle is 50%, and the bottom waveform we have a 10% duty cycle because the time on is very short as compared to the time low. Okay, thank you.